Hello everyone, my name is Kollin Dix-Krebbs, and today I'm going to be going over the instrumentation of a Bldc motor, also known as a brushless DC motor, and its operating characteristics. A little bit about myself is I am a senior at Central Washington University, and I'm studying electronics engineering technology, which is also known as ET. First, I'm going to go over the abstract. In the abstract, it talks about what a Bldc motor is and how I will be setting up my project. So first off, a Bldc motor is an electronically commutated motor instead of using brushes. The way I'll be instrumenting the Bldc motor and being able to look at the operating characteristics is going to be done by using National Instruments CompactRio, which is also known as the NI CompactRio. This will be done using the LabVIEW VI software. When it comes to driving the motor itself, I'll be using the DM183021 brushless DC motor controller, which will be using MPLab. Originally, the plan was to use an NI9502 Bldc motor driver module, but unfortunately, due to technical issues, I had to change that into the DM183021 microchip board. When it goes to the introduction, we're going to be going over exactly what aspects are needed to look into when running and instrumenting a Bldc motor. The first one is how to set up a program in the pulse width modulation signals. That also stands for PWM signals. This is important because these signals are used to commutate the windings of the motor in a specific sequence, which creates a dragging scenario, which allows the rotor to be driven in a circle. That takes us into the next part, which is the motor driver itself. So the motor driver in this case is going to be the DM183021. A motor driver consists of an H-bridge. The H-bridge will take the PWM signals and convert it to a three-phase. This allows for the motor itself to then be hooked up to the driver. And that brings us to the third aspect, which is the motor itself. When it comes to testing the operating characteristics, I'll be using a current Hall effect sensor. This will be done using the NI9201 module. That is in this sense an analog to digital converter, because we need the signal, which is originally going to be analog, to be converted to digital in order to read that in LabVIEW. The next part that I'm going to be going over is in the bottom left, figure 1. That is the current sensor design. This is the setup that is used for the signal conditioning of the circuit. On the left side, you can see the pinout and what exactly the pins will be going, like the pins of the current sensor itself, and what inputs will be going into those pins. So on the right side, you can see the inputs that would be sent into the signal conditioning circuit in the middle. The middle aspect is the components that actually do the conditioning to the actual signals. There's going to be some capacitors and a resistor in there. This allows for the signal not to have as much noise in it. And then the output will go in, the output from the current sensor itself will then go into the NI9201 module, which will be read in LabVIEW. That will be talked about a little bit more in just a moment. In the top middle is an assembly code. That assembly code goes over exactly what will be done. Like, that goes over how the motor control works, and that sets up the motor controls and also sets up the PWM signals that need to be sent to the driver and allows us to communicate with the driver itself. The assembly language itself is used to communicate with the microchip. Also in the bottom left corner at figure 2, you can see the CompactRio box, which contains the motor on the bottom right of the picture, and then in the bottom left is the current sensor circuit itself in person. And the cRIO is in the back, which is connected to the NI9201 module. That allows us to access the LabVIEW software and be able to send information between the two. In the middle, you can see the methods and materials. So we go over some of those materials. We have the NI9201 voltage input module, which takes an input voltage and that sends it into LabVIEW. And LabVIEW, you can display that information or change that information into a certain whatever you need it to be. The 9076 cRIO is an embedded controller that is in real time. And then if you look at the next item on that list, you see the HOP SP33 Hall effect sensor. That is the current sensor that I will be using. Below that is a DM183021, which is the PIC-DEM-MC development board. And then we have the Hurst DMB BLDC motor. That's the motor that I'll be using. Some softwares we're going to need are the LabVIEW VI for 2019. And then we will need the MPLAB IDE version 8.6. Those are the softwares that will allow us to communicate to the board and to the NI9201 module. Inside the methods and materials, we also go over the transfer function. So a transfer function is used to transfer one type of thing to another. So in this case, we're going to be transferring the voltage output from the current sensor into a current. This is done using the equation given there. That equation was derived from the output ranges on the current sensor's data sheet. This allows us to then change the voltage into a current. And below that, we see the LabVIEW code. So in that LabVIEW code, it takes in the voltage, and then it goes through a formula. It also displays the voltage, and then it goes through a formula, converts it to a current, and then displays the current. In the top right, we see a graph for voltage and then a graph for current. On that current graph, there is also displaying the current that is calculated from the LabVIEW and then the current that is being measured from the circuit. You can see that there's a slight variation. It's not very much. This is because certain aspects of measuring currents can actually change the current by just a little bit, but it allows us to determine if our current sensor is working properly, and in this case it is. Overall, that is important because that means that we are able to measure our BLDC's operating characteristics. When it comes to some things that I've learned about in this, when setting up a BLDC motor, you need to look into the correct wiring setup, which is given to in the data sheets. You also need to look into make sure that the proper power is being supplied, so that way all of the components will work properly. Some other aspects that also come up is the version of the software. Certain versions aren't capable of working with others. In total, this project goes over the basic design components needed to instrument a BLDC motor. It also covers the goal of this project, which is, and ultimately the goal is to teach people some of the challenges and processes required to set up a BLDC motor.